so we now know how to solve to figure them out, right? We take each factor, set it to 0, and we're going to solve. So we can get what the answers are. All right, so we're going to say 3x plus 1 is 0. X minus 3 is 0. And we're going to solve each one of those individually to figure out all of our solutions. So I'm going to minus 1. So I got negative 1/3. Could you please figure out the other solutions? Take each factor set to 0. Yes, you can get fractions. Yeah. I guess you could. Most likely it'll be written as a fraction, but it'll be fine. At what? Plus and minus, yeah. Okay, sorry. I'll pause the other. 5. There's 5 answers. 1, 2, 3, 4, 5, because I and negative I. There are 5 answers, which means this is a degree of 5.
I have a question. Okay, so those x's, that means there's 6. That's 6 is a degree.
Yeah. All right, now if I were going to put this in my calculator and graph it, how many x-intercepts do you think we'd see? 3, 2. Which one? Why are y'all saying 2?
3.
Well, there's 3 real ones. Let's do that. There are 3 real ones. Let me write that one down. There are 3 reals. Would these 2 make 2 x-intercepts or 1? This would just make 1. So this would be 1 x-intercept. Here's another one. 2, and I won't be able to see the I ones, right? So there would be 2 distinct zeros that I could see graphically at a glance. How many were imaginary? Do we have any multiplicities? The identical answers, yep. So these would be multiplicity. So x equals 3 with a multiplicity of 2, because it happens twice. What do you think the y-intercept would be? So if we're not going to, but if we can multiply all that together, what do you think the last number would have been? 9? Okay, let's do 1 times negative 3. So negative 3 times another negative 3. Positive 9 times 1. 9. So our y-intercept would probably be 9, right? That would be your constant. Okay. Well, we'll put it in the calculator and look. Yes? There's just the one multiplicity. A pair, yeah. Okay. All right, let's look at the next one here. What if we had a graph and we were asked, write the polynomial of least degree? We're going to write it in factor form. What do you think the answers would be? What does x equal on this graph?
-3.
-3 from right here. What's another one? 2 right here. And say 1, 2, 3, 4.
4.
Yeah, it's 5. All right, so these are the answers or the zeros or the roots. If we want to write the function in factored form, what would the factor be? How can we make this 0? Yeah, we could add 3. So we'd have x plus 3. What would make this as a factor? x minus 2. And this one? Okay. So the zeros are negative 3, 2, and 5. The factors, all right, are x plus 3, x minus 2, and x minus 5. So we could pull them from a graph even. Questions so far? Is the connection clear between the graph, the zeros, and the factors? It's whatever would make it 0. Yes. Yes. All right. Okay. So now here I've given you some zeros. We're going to write the function. We're going to write it as factors, and then we're going to write it as standard form. Okay? So if we have 3 as one of our answers, what would be its factor? Oh, goodness. So this means x equals 3, x equals 2, x equals negative 1. So what would be its factor? What about for x's 2? X minus 2. And there we go. All right, so that's what it would look like. Oh, let me put my little f of x. That would be factored form. If we want to get it in standard form, we're going to have to multiply all this deal together. Okay, so we're going to box up 2 of them. We can choose whichever 2 we want. Let's do the first 2. I'm going to do these 2 together. So it's boiling, right? We've done that before. So x times x times negative 3, negative 2 times x, and a positive 6. Combine like terms. So we have x squared minus 5x plus 6. We got to take this and multiply it to x plus 1 now. So our step here, this one has 3 terms in it. Give everybody a minute to write down their box. We're going to multiply all of that together. Yeah, each other. So we got these 2 to go together. 4x squared, and then these 2 here would go together. There's our function. Okay. How many x-intercepts would you see? 3, right? You can only see the real ones. Here they are. How many solutions would there be? We already know there's 3 of them. They told us that. How many are real? 3. How many are imaginary? Any multiplicities? No, there's no identical answers up there. What's the y-intercept? 6. Good. Right there. It's positive. Yeah. Okay. How many terms does this bottom number or bottom function have? How many terms are there?
3.
Let's count them. Separated by pluses and minus signs. 1, 2, 3, 4. What? Just wait. Okay. Which one doesn't count? No, it is its own term. It's a constant term. Okay? It doesn't have an x with it, though. All right. Is it quadratic? Is it cubic? Is it quartic?
Cubic.
Cubic. How do we know it's cubic?
It has a 3, then that's 3 times.
Okay, good. And what is the degree of this function? 3. Wow, y'all know lots of stuff. Yes. Y'all know lots of stuff. Wow. Back to you. They want to know that imaginary numbers come in conjugate pairs. I'm talking about EOC. Your final for Algebra 2. I do not. That's a state thing. So this 2i, it's 10. It's like your final exam. Okay, so this 2i, if there's a positive 2i, which other one has to be there? Negative 2i. The conjugate gets put in there with it. And they're not going to tell you that. They're going to expect you to know that. Okay? So if we want to write the factors for this thing, we have, so first of all, the answers are x is 4, negative 3, 2i, and negative 2i. Let's write all of its factors. X equals 4, what's its factor? FOIL it. And I'll do it up here as well. It doesn't matter. Either way. Either way. So when you box it up, are you noticing you get a 2xi and a negative 2xi? What does that make? 0. So Kendall's right. So it's going to cancel one another out. So this is now gone. What's I squared? -1. So this is really plus 4. So we have x squared plus 4. And then we would multiply it with... And then we'd have to multiply again, like we did in the previous one. Okay. Yeah, that's okay. All right. So let's kind of go through our spiraling back here. How many, what's the degree of the function? How many answers were there? 4. We had 4 answers, so the degree must be 4. Okay. How many zeros are we going to be able to see? Distinct zeros, x-intercepts. How many? 2. We can't see the imaginaries. Okay. We'll only be able to see 4 and negative 3, so there's 2 distinct zeros. How many solutions are there in all? 4. How many of them are real? 2. How many are imaginary? 2. Any multiplicities? No. We don't have any identical, right? No identical solutions. Okay. All right. We're going to stop here. You can pass out.